All right, hi everyone. Happy new month. Welcome to December. I hope we are all doing great this evening. So welcome to class, and I wish us all the very best in this new month, and same in our section today. So today we are going to continue from where we stopped, and that was on regression problem. So we pick it up from there. I know that a number of us has also been trying out one or two things. Please let me know when you can see my screen. All right. Okay. So we just kick start now. Okay, so from here, very close to what we've done before now, which is importing necessary libraries. We are importing pandas as PD, we're importing matplotlib, Python plot as PLT, we're importing Cborn as NS, we are still importing sklearn, we import warnings, we are importing from sklearn preprocessing, from sklearn we are importing KNN inputter, from sklearn we are also using model selection, we are importing train test split, from sklearn we are importing preprocessing, and we are importing standard scalar. From sklearn metrics we import F1 score, from sklearn assembly we are importing random forest regressor, from sklearn model selection we are importing cross validation. These are standard ways of importing what we have. Also, for this particular task we're about to do now, we are going to be using a data set called position underscore salary. So all of these are already available in data underscore cleaning ML. There's a folder called data cleaning. So most of the work we are doing are available just here for us to be able to access it. Okay. Okay, so that's the first thing we're doing here. We are importing all of these libraries. So the next thing is to load the data sets. So pd.read.csv, we can see from here, this is the file. This is the file we're working with. It's a CSV file from the extension, and it has position, it has level, and has salary. All right. So if we load this df.eld, we can see here we have business analyst, we have junior consultant, and all of that. So df.info, so here we can see we only have just 10 records. That's a lot, that's just small data as it were. So we check df.shape, we see that we have 10 records, 10 rows, and 3 columns. Um, so the next thing from what we've learned, majorly now we only have 3 columns, and of course, salary is what we want to predict. We want to predict what salary somebody is going to be getting, right? At this point. So if you look at how we have here, salary is our target. The only column here that is really useful is level, right? Position, I'm not sure at every point is that very important, but of course if you also feel it's important, all you just need to do is to all you need to do is to encode the position. But at this point I think level is the only key thing. Based on your level we can be able to predict your salary like that, as it were. Okay, so if you look at what we have here, so we are splitting our x and y. You can see here the approach we are using here is the ilog. For many of us, we have talked about ilog. Ilog talks about index location when we are talking about our numpy. So the goal here is we want to select all the rows. Don't forget, we don't have too much data here. That is why this is the approach we are using. So this type says we are trying to select the rows within the range of 1 to 2. So this will help us to select the rows 1 to 2. 1 to 2 simply means it starts at 1 and ends at 2. So this is for the column. So that means the only column that will be here is what is this one. All right, so the column that will be here at this point will just be this guy level. Okay, that's the column is going to select. Why for the y, which we know the y is going to be the what is going to be our target. And from what we have here, the only same thing we still want to select all the rows. All right, index location. Okay, so say more like the row. And of course, here you see our y will be df dot iloc. Iloc is still talking about the rows we are trying to select from. And of course, here we only want the column 2. And column 2, if you follow what we have here, is going to be what? Is going to be salary. It's because this is 0, 1, 2. 1 to 2, 1 will be level. I hope we still remember that. So if we run this, so from here, please take note of the things we're trying to do here. So from here, if we look at from sklearn.ensemble, so if I run this guy, let's look at what is in our X so that we can have an idea of what is selecting. Then our Y, what's in our Y? Okay, so you can see that is this data that is there. Let's see. So you can see all this one, two, all of that is primarily selecting all the levels, and our Y is selecting all of these guys, right? Now, like I told you before, at times you might think that it is number that is inside a particular column. Most time, even though it's looking like number, in the real sense, it might not really be number. It could be, an ordinal thing. It could be looking like number, but in real sense, they are classes. Because, for example, this level now, they are not number one, number two. They are level. It could be two. So people, another person can also be in level 2. Another person can also be in level 2, like that. That's a picture of a classification. All right, that's a picture of a class. That is why here, just to show you, and like because somebody has asked before that in a case whereby we have categorical feature, right? How do we handle that? One of the things we do is we preprocess it by doing encoding. I've mentioned that before now. So sorry, I guess my screen went off. Oh, so sorry. So I hope you can see my screen now. Okay. So we pick it up from there. I guess you add the things I said. I'm going to just look at the screen to talk about them again. So sorry about that. So from here, we are importing necessary libraries for the kind of tasks we're trying to do. So we import pandas as PD, we import patrol as PLT, we import Seaborn as NNS, we import sklearn, import warnings. So from sklearn preprocessing, we imported all of these guys. So I mentioned the data set we're working with is position salary.csv. All right. So from here, the data, like I mentioned, the file is already in this direction. You have the data underscore cleaning MIL. Data cleaning is another subfolder there. So you will see the position underscore salary is there. And of course, I opened that to show us what it looks like. So we have position as a column, we have levels as a column, then we have salary. Okay. So with this now we can see that this has just very small data that we can leverage on or that we can work with. All right. So that's what we have at this point. So what I was showing here, we are inside the linear regression notebook. So when we run this, just this is going to give us the top 5 records. df.info shows all the columns that we have, the number of records, and of course from this we can see that there are no missing data. df.shape gives us number of rows and columns. Okay, so this approach I mentioned, when you see iLock is talking about index location, more like you're selecting all, this one says you are selecting all the rows. And of course, you see 1 to 2 by index. So if you look at this now, so a range of 1 to 2 simply means you're going to exclude uh, column 2. So you're only going to focus on column 1, which is this guy. All right. So that means the only column that goes into our X is level, and Y, we're selecting iLock, which is all the rows. Then the only column that goes here is salary, which is our target. So we want to be able to predict the salary of a staff. Of course, that kind of problem is a numeric problem. All right, that kind of problem is a numeric problem. Okay, so if you look at this X, you can see the numbers that are there. My Y also, the values that are there. So import pandas as PD, just to show you again. I know we have done some importing before. All right. From sklearn.assembly, we are importing random forest regressor. From sklearn, preprocess, and import label encoding. Like I said, somebody mentioned or asked about how do we handle a situation whereby we have a feature in our data that is numeric, that is categorical rather, and this maybe for example gender and all of that. Gender, like we have here now, level, or say we have position, all right, which means that it might have the values of classes. And the feature can also be very important in whatever it is that we are doing, based on our domain knowledge or based on our activity or based on our tasks. The feature might be very necessary or very, very useful. So one of the things that we do at that point is that we encode it. And there are several ways of encoding your categorical feature. One of the approach we use, and one of the method I used to use, that I recommend a number of times, is label encoding. Label encoding, all right, is label encoding. One of the methods that we can use. Of course, we have many techniques of handling these things, but one of the approach we can use is label encoding. Of course, we have, several techniques, and like I've told you, what we are doing is experimenting, because one not encoding can work more on the particular data set and give you better results than label encoding. Same thing like we talk about our standardization and normalization. All right, it simply means, that at some point, you can also have you can decide to do normalization and do standardization. All right, we have different techniques, different types we can do based on what we have learned so far in this class. But like I said, there are no better ways to answer the question than to try it out on your data. So once you try it out on your data, you will know how much it's doing. Somebody saying, why are we importing warnings? Okay, so because some particular libraries can actually can depreciate, the version thing, right? So that might always want to pop up some warnings. Even when you are building model, you see some warnings just trying to tell you something that is happening in the background. So you might want to ignore that. Warnings are different from errors. They're just telling you, it could tell you, oh, for example, many of us you see is asking you on your system to that there is an updated pip that you should install. Those are warnings. It's telling you, oh, this particular version is depreciation is deprecating, right? So what it's doing at that point is just giving you some insight, giving you some hints to what is happening, right? So most time when we import warnings, you possibly want to just ignore it, right? Or you also might even want to get the warning. So it depends on you. So most time we import it that way to avoid all these warnings that it says within the code. All right, so we use label encoding for that. Like I mentioned, it has to be a feature that is numeric, that is categorical. It's taking class. And like I told you, at times too, even number can be categorical. For example, level is not a continuous number. Level will mean that we can have two people who are in level 2. Which means that we can have about 100 people in our company who are all in level 2. That's a categorical thing, because it's not a continuous thing. That means they are all junior consultants. We can have 20 people who are managers. All right, that means that that level showing number does not necessarily mean an order. It means their position, because more than one person might have that value, as it were. So that's a picture of how at times to us it's looking like a numeric feature, but in real sense they are not. It is not really numeric, but of course it's looking like number. And that's why as you begin to understand your data, you will understand the place they are. For example, you look at salary now. Salary is number, right? So it's a continuous number. Is, salary is, a continuous number like that. But level, it might change over time. All right. So that's just showing us some of the knowledge we might want to have about your whatever it is that you're doing. Okay, so if we continue from here, if you look at the first part of X categorical, so I'm saying that from my DF, select all the data types that are what? Objects. So that means from my DF now is trying to select all the columns, which your data type is what is objects. Then apply what on it? Apply this label encoder. Don't forget that this label encoder, I'll store it as an object so that I don't have to be saying this label encoder. I'll just be calling this guy's name. All right. I call that label encoder dot what? Fit transform. Then in my X numeric, what do I want it to be there? You should select all the features that are not objects. You can see saying exclude, not include this time. Exclude objects. This one, the ones that are categorical, you should include what? The ones that are objects and apply label encoder on it. You can see it from here. You should apply label encoder on it. So df dot select data types, include objects, dot apply label encoder dot fit transform. While my X numeric, df dot select data type, exclude object dot value. This all the features that should be here should only be numeric features. All features that should be here should only be numeric features. All the others that should be here will only be numeric features. Okay, so you can see here now, because the numbers we are having are in two formats. So if I run this guy, you can see me now, concatenating a number of things together. All right, and concatenating here means that they are all X value, but some of the X value will be numeric, some of the X value will be categorical. All right, X equals to 1, so I'm concatenating these two values into my X. Is the real value of my X now. And don't forget, what's the value of my X? The value of my X is this guy. So what I mean here is that I want you to see one part of my X as numeric, another part of my X as categorical. That's what I did here. That's why I split it into X and Y. All right, and here we concatenated them together. Here we now decided to call our function, our model we want to use. So the model we're trying to use here is what? Random regressor. Random regressor. So if I do shift tab on this, we'll be able to see all the parameters that comes with my random regressor, random forest regressor. We have the number of estimator, the central, the maximum depth. You can always read about the peculiarity of all of these parameters, right? So I'm using some. Of course, you can also Google it. It's also allowed to read about the best parameters. So I can come online. Let me share this screen. I come online and say, what are the best parameters? Because these are the things because some people are actually going to ask, how did you get that? It's from research, it's from knowledge, all right, that you get them. So I can say, what are the best best parameters, or I say tuning parameter for random forest regressor for, and of course I'm using for one features. Don't forget, I'm just using one feature, right? From what I have. So for me, so you can see it's always going to bring something that you can learn from. So if you look at this now, you can see tuning the parameter for your random forest model. This is the latest material. So you can see that all the things we are doing is about how much we can make research, right? It's about how much we can make research. If you look at all of the things that are here, so I need to continue with either my Google or something so that I can see. I'm just showing you this because those parameters at some point, You will need to research will help you to know how best to handle them. All right. So you can see they try some stuffs here. I can see this is very close to the one I'm using, which is like, the parameters that you can decide to use on your model. So these are, you can see what they are saying here, feature which makes the model train easier. These are information you, right? These are the informations that you might want to, because every feature, every model has their peculiarity. This is somebody who has tried it out, who is now giving us something we can try out. So I can decide to copy what this guy has used in as his own parameter on what I'm doing. All right, on what I am doing. So instead of using what I have here, I can decide to override it with what I copied from research. All right, I'll just put this here so I can just change this parameter. So there are no better way or best way of doing this than trying it out. Okay, than trying it out. So I will try his own. That might even improve the way my model is going to do. All right. Okay. So from here now, you can see random forest classifier. We have the n estimator as 100. OOB underscore score should be true. Number of just -1. Random state. Of course, to know what those guys are, you can always do shift tab here. So here, shift tab, you can read about all that you mean. You can see all the things I put there, they are all available as part of the parameter. So if I run this, then this is where I call my model, just to put some comment there of my model with some parameters. Then here I train. So here I'm training my model. And now somebody might want to ask, oh, how come we did not split like we used to do? The reason why we are not able to split it is because we have very, very small data. It's just 10 records. All right. So we can't split that. What are we going to? Right. So what are we going to split into? We have very, very small records, right? Very, very, very small. Okay, so it's very, very small. That's why we did not do x train, y test, x test like we did before portion we were splitting, last week. All right, so that's why we could not do that. Do we get that? So because we have very, 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 very timing, the data is very, very small, but it's just a proof of concept so that you understand what we're trying to do. Okay, so here is where we fit the model. You say true, not divine. Where are we? Okay, this is not even happening. My data. Let me go and check where I'm trying to copy it. If there is something I'm supposed to call before this, and if that doesn't work, that means that style does not work within my code. So I just fall back to my previous. I'll fall back to my previous parameter. Okay, no, true. I guess it's just the way the true is mentioned. Let's see it again. Okay. I think it's even very close to what we have here before now. Okay, this is using 50. What else? MB job. Okay. Do you mean comma? Where is that? Yeah, there should be a comma after this. Thank you. Okay. So good. So now you can see here I have called my function with some parameter. Call my function with some parameters. Here's where I'm training the model. So let me ask again, why are we not splitting our model into 4 portions like we did last week? Just to be sure you understand what we're doing. Anyone? Yeah, because data is small. Yeah, thank you very much. Data is small, so we might not be able to do that. Okay, so from here, we move again. Now we have just fit our model. Like I told you in the last class, that we have built a model is not the big deal. The big deal is how is our model doing. All right, how is our model doing? So a few metrics that we can use whenever we are building a regression problem. One of them is mean square error. I explained that last week. Also, we have the R square adjusted R square error. So we are, don't forget, we're importing this from what, sklearn dot metrics. All right, so you can see the number of specifically this is where we use them, this guy here. So you can see here where we say prediction. After we have built our model, the next thing is to predict. All right, so prediction is regressor dot predict. You can see it's on that x because we didn't do x train, y train, and all of that. So it's still the x we are going to be passing. So from the result of our x, we can say MSC will be mean square error that we are calling here. And of course, that will take two parameters, our y true and our predicted value, the actual value of our y and the predicted value. So most time, whenever you are trying to evaluate, those are the two parameters you will pass there, whether it's a classification problem or regression problem. We're trying to find the metrics. We're trying to evaluate your results. It's going to be what is in the data and what are we getting. All right, what is in the data and what are we getting. All right, so from here now we can see our mean square error is y, which is our actual y, and prediction, which is the one we now predicted. So here we are printing the mean square error for that. Why the R2 is what? R2 score, which is this guy here. So we are passing what, our y and our prediction. So if you run this guy, you will see the result. So out of the box score is at 6%. Mean square error. Can you see the number of error? A lot. This is a lot of number. This is a lot of number. R square error is about 98% error. Imagine, error. R with 98%. What did we now build? But this, what are the issues with this? One is the data. That's why we used to talk about data whenever we are talking. That the more the data, the better the model perform. All right. So because data is also very small, all right, that is going to be a lot of issues. And you can see from that result that I just showed you, data is very, very small. But then I don't want you to understand the concept that we use in building our model. So if you look at the processes now, since what we have done since our last class, the first thing is you need to clean your data. You need to preprocess your data. Do you want to scale it? You want to check the correlation to understand how your feature is doing on your target. Features which has a very high likelihood, target features like that are not very good to be used when you're building your model, because that can also lead to overfitting. All right, so you want to try out, of course, these things that I'm mentioning, we're still going to understand them as we begin to move on. But if you look at this, we have a very small timing data, and with that we are just using our x directly. Now from this result, now it tells us, one, our error is a lot. Can you see this is a million? If the goal, don't forget, what is the goal of these matrices is to reduce error, margin. So if error is this plenty, what have we not done? If the R square is 98% error, almost 99% error, what have we done? So this is not good at all because of the result. But of course, we know that we are getting this result because of the data set we work with. It is extremely very small. Nobody builds data models on this kind of data set. But this is just to a show and proof of concept. A show and proof of concepts. So any question on what I've shown you? Somebody saying that the error is plenty. Yeah, definitely. Yeah, the error is a lot. No doubt about that. And of course, we have been able to identify why the error is that plenty, because of data we are working with. So any question before we move on? Can we use another method, or may we get another lower error margin. So for this kind of task, I don't think you need to stress yourself. The problem is the data. So when data is bad, there are little to what you can do, at that point, right? So there are nothing serious you can do. On this case is a very unique case, and the uniqueness is that this is a data problem. Do you get? So if it's a data problem, it's difficult to handle that. But of course, if it's a real data and your error is this much, there are many things we can do as we move on. We'll talk about them. All right, we'll talk about them. So how do we define a small data? Is it by megabyte size or by its cases? Okay, so if data is much, the size also you will see it from the size. But the number of records you get, the more the records the better the data for you. So how do you know your data is plenty? When you check the shape of data, it tells you as is much, right? If you begin to have data from at this level, at least if you have data as far as 1,000 at this stage, as far as 2,000, and of course you begin to work 100,000, 200,000. Not of course, like I said, all of this also we have is some level of effect on the size. But of course, because some of them can also be light, right? So it's about the number of records that you have that tells you if data is plenty or not. So it's from the records that you have loaded, the data set that you load is what we give you. So other methods we can use, we, we keep talking about that as we move on. Okay. So let's continue from here so that we can follow what we have here. So we've talked about this before, but I'm going to talk about this now in the context of talking about classification problems. So you can see all we did all through last week and now is how we can work with our classification, our regression problem. The processing, all the same thing. Processing is going to be the same thing. The only thing that changes is the kind of model we are working. And don't forget, we are all that we are doing is focused on supervised machine learning. That is, we will always have our targets. All right, we always have our targets. So here we are also talking about supervised learning, whereby we established last week that we have two types of supervised machine learning: classification or regression. Classification, we are predicting discrete labels or categories. For example, we are predicting, is it a spam email or not? Does this person has diabetes or not? At that point, it's a classification kind of problem because we are not predicting continuous numeric values. But regression is when we want to predict continuous numeric value. At that point, we are trying to predict continuous numeric values. So classification in machine learning, well, I've mentioned that classification is a supervised learning technique that we use to predict labels or categories based on input data, based on input our features are the input data, right? So the model assign each data point to a predefined class. For example, spam or no spam, diseases versus LD. So those are the possible values you might want to get at that point. For example, a model training on labeled dog versus cat images can classify new image to either be dogs or cats using features like color, their texture or shape. Now let's talk about classification, which is the kind of problem we want to look at now. So there are different types of classification problem. All right, please take note of this. The first one is what we call binary classification. So that's the simplest type of data that you can work with because it will only have two categories, which is either spam email or not spam email, right? Spam email or not spam email. Uh, cat or dog. So when binary means 0 and 1, so 0 could mean spam, 1 could mean not spam. All right. So at that stage, it is a binary class. So once it only has just two categories in your classification problem, you know that is a binary classification problem. But a multi-class basically has more than two categories. A multi-class classification problem has more than two problems, that is two values. For example, it can either be positive, negative, or neutral. When the classes has more than two categories, that is a multi-class classification problem. All right. So most times these are the two common, kind of problems you are going to work with, most of the time. All right. So you have to know. So of course, it's a classification problem. Is it a binary classification problem, or is it a multi-class classification problem, or is it a multi-label classification problem? This is whereby you have more than just one column that you're paying attention to. Okay, so in multi-label classification, each input can belong to multi categories at once. For example, a movie can be tagged as action and also a level of comedy, right? At that point, of course, at this stage, you won't have that kind of problem at this stage. But just to tell you that you can have two more than one value for one result. For example, a movie one can be action and comedy. Movie two can be um, crime and action. Movie three can be action, comedy, and crime, right? So that is, but of course, at this stage, that will not be a kind of problem you want to focus on. So how does classification works? Very close to what we have been doing before. So how does classification problem works? One is you need to get your data like we've been doing before. You need to do your feature extraction like we tried, on our regressor kind of problem. You need to do model training. You have to build model. You have to be able to evaluate your model. You have to predict on your model, iterate improvement. That is, if your model is not doing well, how can I improve it? So classification algorithm. So on understanding logistic regression, which is like the essential, the first model we need to try out is called logistic regression. Now, it's carrying the name regression. It is not for linear regression. Oh. So it is called logistic regression. All right, logistics regression. So understanding logistic regression is essential because it's one of the most fundamental classification algorithm. However, machine learning offers many linear and non-linear classifiers. One of them is of the linear classifiers is logistic regression. We have linear support vector machine. We have single layer perceptron. We have stochastic gradient descent SDG classifier. These are examples of models that are linear, in their results. While non-linear classifier, we have the K nearest neighbor, we have the K kernel SVM, which is support vector machine. We have the naive Bayes, we have the decision tree classifier, we have the assembling classifiers, the light of random forest, Ada boost classifier, bagging classifier, voting classifier, extra tree classifier. We also have the multi-layer neural network. These are not in the context of what we are doing here, but just to inform you about what we are doing. Also, some real life examples just to help you understand how this work. Just to help you understand how these work. Okay, so we have the email spam filtering. That is, one of the problem here is that we want to be able to identify if an email is spam or not spam based on the text pattern. Also, another problem could be credit risk assessment. We want to predict a loan applicant is likely to default or not. Okay, medical diagnosis. For example, we want to be able to classify a medical data to identify diseases like cancer or diabetes. For image problem, we can look into facial recognition, autonomous driving, medical imaging. Also, another kind of problem you can want to do, especially if you are doing natural language processing, is sentiment analysis. Based on the features, you want to predict whether, based on the tags, if it is a positive review, if it's a negative review, or if it's a neutral sentiment. Also, fraud detection is also there, detecting fraud activities by analyzing patterns in your transaction. Also, another kind of problem you might want to work with is recommendation system. Here, we want to be able to recommend item based on user behavior, right? Based on user behavior. For example, Netflix movie, Amazon products, Jumia products. That's why you see that if you click on a Jumia product. For example, you're trying to buy a shirt. Because you brought a shirt, it's going to recommend maybe a tie to you, or a trouser, or even a shoe. These are possible recommendations that you can get. So all I've done with this material is just to give you an overview of the possible things that might be happening, or the kind of problems that classification will fit into. So there are more problems that are classification inclined, than others. So so what so before we move to working with a classification problem, let me see if there are questions that might need my attention. What if the data is too large? Will it affect the model performance? The only thing that is happening when your data is small is that it's going to reduce your model performance. All right. So if you have more data, it doesn't really directly mean that your model is going to do well. It's about the metrics that you are looking at. It's about the cleaning you have done on your data and all of that. So it's a whole lot, as it were, really. There are a lot that goes into model performance. But one thing we are sure is that if you have very small data, you cannot build model on that. Meaning that there will be no need to build a model with with build a model with smaller model. Where I guess that person means the smaller data. Yeah, it depends really. All right, if that is the level of data that somebody has, apparently you just use it like that. But of course, in your report, you put it there. All right. So that's one way. So how do we know the model to use? I've said this a number of times. There are two ways about it. One, make your research, because every model that I've mentioned, naive basis, assembly models, linear models, they have their uniqueness, but time does not permit us to start talking about them one by one. So one of the assignments I will want you to do, and I'm giving that now, one of the assignments, this is supposed to be what you should study, is that same question. When do I use linear regression? Examples. All right. When should I use naive basis? So the assignment I'm giving is describe different models, make your read about them, describe different models, and give the best use case for them. When should I use? Because they have their uniqueness. Because some of them are linear focus model, some of them are not directly linear focus model. So they all have a way, and that is one way to do that, is by research. All right, research makes it easier for you to, like what I just did the other time. I was just giving him some parameter because somebody has worked with it and seen that it's possibly better and all of that. Research is one way to know the model to do. Second one is experimenting. It's a classification problem. I can try to build all the classification kind of problem models on it. So two ways is experiment. Second way is research. Read about that model. What is the unique way of using that model? What are people saying? People researchers, what are they saying about that model? All right, like what I showed you the other time. So two ways of knowing what model to use. One, what are people saying about that model? What are researchers saying? What are research papers saying about that model? All right. What are other developers like yourself, data analysts like yourself, machine learning engineers like yourself, what are they saying about those certain, or like those models? Because if you go online, all these informations are there. The second one is then you can decide to experiment, because every data set that you're working with, they are unique on their own. All right, every data set you're working with, they are unique on their own. So that is the two way I'm going to recommend for you to take note of. Okay, so I've given that as an assignment already. So look at different models based on these two kind of problems, because at this level you are going to be working more with regression or classification problem at this your level. All right, unless you are doing some other work on unsupervised, but at this level unsupervised will not be something we want to sell to you. That is something a pretty much very close to what we are learning, right? But at least we are not able to cover that at this stage. All right, so those are few things that you take note of. So please do a thorough research on that. It's going to help you, because they also ask questions like that in interviews, just to know if you have made your research about model and the kind of data that they work well with. For For example, if you have binary classification problem, the first model to think of is logistic regression. Why? Because it's a binary problem, so it works well on zeros and ones. All right. So those are just some, some intuitions, some research that you could have made on your model. What techniques can we use to increase the size of a small data? The only thing you can get at that point is that you can generate synthetic data. What are synthetic data? Synthetic data are data that are not real. You can ask ChatGPT, for example, to help you generate some synthetic data. There are also some platforms that you can use to also generate data, but the difference is that you cannot trust the result of that data because they are not real data. They are just demo data, and you cannot rely on it, right? So the only way is always going to be to look out for you know data sets that are real, that you can depend on, not just synthetic ones. Synthetic are just what we do to be able to prove concepts. We cannot believe on that. Okay. So any other question before we build our classification kind of problem? Somebody is writing linear regression and logistic regression. I don't understand what that person is saying, but they are two different things. Linear regression is like a default model that you should try for regression kind of problem. Logistic regression is a type of classification model, right, for binary. Okay, so let's move on. So I'm moving into a folder, a material called classification is also available inside this data cleaning. You can see I placed everything in the same directory so it's easier for you to navigate. So most of the things we have said before now are the things that are here. So I'll just move directly to the tax. Okay. So like I mentioned, there are certain peculiarity about all these models. For example, we have binomial logistic regression. For example, in binomial logistic regression, the target value can only have two possible values, which is 0 and 1. 0 can mean pass, 0 can mean fail rather, 1 can mean pass. All right. So you can see a number of that, as we work. Okay. Now for this task, we want to also depend on a data set that is available in our sklearn. All right. So you can see here from sklearn data set, we are importing load breast cancer. From sklearn.linear model, we are importing logistic regression. And from sklearn model selection, we are importing train text splits. And from sklearn.metrics, we are importing accuracy score. So you can see from here now, X and Y, we are splitting them using load breast. Don't forget that this guy already has data. I mean, the data, it's easy for us because it's already pre-processed. Don't forget, I said that already last week. The data is already pre-processed. That simply means we don't need to do too much pre-processing on it, because before they can store it here, before they can put it inside sklearn data, they've already cleaned the data. They are already the pre-processing on the data. So all we just need to do is to call that kind of data and split it out. All right. So you can see that's why I'm saying here that X and Y, load breast cancer, return, these are different parameters. So if you check this guy, I need to first load this guy so that I'll be able to do shift tab on this load cancer, for example. So if you look at this load cancer, for instance, you will see the parameters there. You can see X, return X and Y by default is false. You can see, so I say return X and Y. So if I look at this now, you can see the number of information that are classes here is 2, which is 0 and 1. All right. Either you have cancer or you don't have. You can see some data has about 569. You can see the sample information here. This one have 212 for M, 357 for B. So you can see the information about the data, which is also very paramount whenever you are working. This might be looking somehow because we cannot directly access the data like the way we used to load previous data. So from here now you can see here, because at least we have some level of data, so we can decide to. So I'm going to split this guy so that we can take them one by one. Okay. So from here now I can try to check what's in my x. Okay, you can see now x is something that has been normalized, transformed into a format that is easier for the model to understand. What's in my y? My y, you can see 0 and 1, which are these values there, which is in the load breast cancer. If you check it again, you will see those values there. It's taking two parameters, it's expecting two values. You can see. So you know that's pretty much what we have here. So return this guy. If you read this guy, you will see what those information stands for. But you can see that it's a two class, that we have there. Okay, so you can, that's why you're saying 0 and 1, 0 and 1, 0. That means that 0 year, maybe that 0 year with me, he didn't have cancer, he didn't have cancer, he didn't have cancer. One means it has. Do you get what I'm trying to say? So that is, a picture of how our y is. So from there, we are trying to split. We have done this before. We are splitting into 4 portions. Don't forget the x train and the y train again will be used to train the model. The x test will be used to predict the model, while the y test will be used to evaluate the model. All right, to evaluate the model. So you can see from here, we splitted it here. So let's just put the comment again. We split our data into 4 portions. So you can see from here, x and y is what that is where he's picking our x. All this x now is split it into x train, and here too, all our y to split it into y train and y test. Test size is 20%. That means we are training. If we are testing with 20%, how many portion of data are we testing? Are we training with? If we are testing with, excuse me, if we are testing with 20%, what portion of data are we testing? Are we training with? Yeah, so we are training with 80%. Very correct. So from here now you can see in our CLF now we are calling here, we are calling our model to use. We're calling the model to use. And the model we are using at this time is what? Logistic regression. The passing of parameter there. You can also use different parameter. Then the next part is to what? To train your model. And the last part is to test, evaluate your model. And one of the evaluation we can work with in classification problem is accuracy. All right. So you can see from here, we are training the model here, and like I've told you, you can see that this predicts. You can also do it one by one. All right. For example, we can say predict here, so that you are not confused. So we can say y predicts. So that will be what? CLF dot what? Dot predicts on our what? On our x test. All right. So instead of doing this guy here, all right, so we can remove this guy and say y predicts. It's the same thing. It doesn't, because that's the approach we're going to use. All right. So what we're trying to do here is that whatever result it got, we want to get it in percentage, because for accuracy, for most of the classification problem, they are going to be in percentage. And if you decide not to put it, you by yourself, you have to know that you are saying that in percentage. All right. So whether you calculate it in percentage, or you decide to calculate it, or you say it out, all right, it's still the same thing, whether you're calculating in percentage or you're trying to one by one. So the model, evaluation we are doing here is what accuracy. So if we run this now, based on what we have, you can see the logistic regression model accuracy is what 96.49, which is good. But of course, we can't really completely say it's good. Hope is not overfitting. All right, those are things we might also want to check as we continue in our learning. But at least to this extent, you have been able to do what? You have been able to calculate your accuracy. You can move on to either, you can also try, let's say maybe you want to use your F1 score, because there are other parameters you can, you can check here. The only one we have used here is accuracy score. There are precision, there are other evaluation that we can do. But at least with this is a good number. All right, this model is a good one. But of course, we also have to pay attention to check that hope is not overfitting. We will still come back to that. We are taking this thing step by step. But don't forget that for this task, it's just a binary problem. It's just having two values, right? Which is either 0 or 1. Now we want to look at a multi-nominal logistic regression. All right, a multi-nominal logistic regression. That is, at that point, what that simply means is we have more than just one values, right? Because somebody asked me to explain overfitting. I'm going to explain that, but I don't want to explain it yet. Yeah, so let's go for a break. We will be back by 8:10. What is saying accuracy is not reliable? Yes, obvious. I'm going to explain some of these things from real point of view when we are back. So let's go for a break, zip some water, stretch your leg, stand up and walk around. So we'll be back here by 8:10. All right, welcome back, everyone. Okay, so welcome back. Let me look at the chat. Um, Not too much. All right, so let's move on. Somebody's asking, how did we get 80? So that means if we test with 20%, we're talking about 100 here. So if we test with 20%, that means we are training with 80. If we test with 10, that means we are training with 9. That's the logic behind that result. Okay, so let's look at a multi-nominal logistic regression. Here we have three possible answers, all right? Three possible results, as it were. Now, disease is A versus disease B versus disease C, classifying images into cat, dog, and bird, predicting types of fruits, all right? So, at that kind of cases, you have just more than two values. So unlike binary logistic where we use small activation function that is just 0 and 1, for multinomial we use suffix softmax function. I'm not paying attention to all of these guys here because I don't want to bore you with the mathematical inclusion, but just know they exist. For a model predicting k classes, the softmax function is used to convert the raw model scores into probabilities, where the k is the total number of classes, the z is the vector of the scores, ij indicates the iterating over all elements. So softmax ensure that all output probability are also between 0 and 1, even though you have more than one. So what will happen at that point is, for example, you have this is a b c. Let's say for that particular record it is c. That means at that point is going to give you one, and at that point that one will now mean c, other one will be 0 0. That's the kind of format you're going to get in that result. And of course the probability for the classes is sum to 1. Now let's look at an example here. Also from our data set we are loading load digits, all right? From here we are loading digits. Our x is digit.data. Don't forget that all this is happening because we are working with already existing data, all right? We are working with already existing data. That's why it's looking as if it's straightforward. In real problem, you need to be the one to clean your data. You need to be the one to pre-process your data, So don't forget those things. That is looking direct. Doesn't mean that's how it's going to be direct. All right. But we are using those examples so that we can quickly learn the concept of modeling. But in the real thing, the way we have followed it through before now is still the same way you're going to follow. Still the same way you're going to do it. Okay. Just to clear you on that, and don't think it's just one line. It won't be like one line in the real data you're going to be working with. But most of these data are already pre-processed, all right? They're already pre-processed. So it's easier for us to just plug into them and use them for whatever finding or whatever task that we have gotten. So from sklearn.model selection, we import tra- train text splits. From sklearn, we import data sets, linear models, and the metrics. So the data set we are working with is what we store here into digits. Our x is digits dot data. That is the format it is in the what we're working with. Y white digits dot target. That's the the column name that we're working with. So x train, we are switching that. So if we are testing with 40%, that we are training with how many percent here? Yeah. So we are basically we should start from scratch. You understand what you're saying? What we are doing is from scratch now. Did you join the other classes? Okay, so we split our data into four portions like we've been doing: X train, X test, Y train, Y test. So we train test splits our X and our Y. All right. So if the test size is 0.4, what does that mean? That means that we are testing with 40%, then we are training with 60%. And don't forget the goal of the random state. The goal of the random state is that it's going to retain that state so that it doesn't change the values that goes into your X train, X test, Y train afterwards, right? So for the model, we are using logistic regression from linear model, and we are fitting on X train and Y train. We are predicting on X test. These are the normal formats that we have been following before. Then the evaluation we are doing here is still what? Is still accuracy, all right? Just to show us the approach that we have been using before. So if you look at this, you can see that if you have a total clean to the point where you are splitting, you can see that this is all you just need to do at that point once your data is in its right form. All right, this is just what you need to do, which makes it a bit easier, or that looks like that also makes it look as if what we are doing is not really serious or something very technical. But that will always be the approach once your data is clean. Okay, once your data is clean once your data is clean. So let's evaluate other evaluation on our model. For example, in this digital classification task, the logistic regression model predicts one of 10 digits. Either you have zero, or you have whether you have zero, or you have one, or you have two. I mean, that's the digits that three, four, like that. So the possible values you can get are between 10 digits. All right, are within 10 digits. All right, it should be 10. So based on the image features, so to ensure the model generalizes well to unseen data, we evaluate it using several classification metrics. So what we want to talk about now is what are the metrics to know if your model, a classification model, is doing well. All right, like we were doing when we were doing our all right. So if you look at when we are cleaning our data, for example, uh most of the things that we are doing when we are doing our linear regression problem, if you remember, at that point we saying 80. If we are training with 40, if we are testing with 40, we can't be still testing with 80. Oh. Don't mix it up, oh, Steven. Okay, so if you look at what we have before, you see that when we are training our data, all right, for regression, we are doing RSME, we are doing R2 square error, we are doing a lot of MSC and all of that. Those are the evaluation that you can try out whenever you are doing regression. All right, but for this one, whenever we are doing classification problem, what are the possible evaluation you want to try? I've told you the evaluation is the one that gives you a pointer, is the one that guides you to what it is that you are doing. It's the one that gives you a clearer picture of what you're doing. All right. So, which is always something you should pay more attention to. So, the first one we are checking here is accuracy. So, what is accuracy? Accuracy is true positive. What does true positive mean? True positive is talking about the ones that are actually true. That is, for example, let's say you are working, let's use a case study of um, pass or fail. All right. So let's say that's the kind of person you're working with. Pass or fail. What does true positive mean? It simply means that this guy, true positive means that this result is predicting to be true, and the ultra also is true. True positive is talking about one is true. True is our result here. The values here is true. That is what that means. Oh, the value here is supposed to be pass, and it also predicted pass. I get what I'm saying now. But true negative means that the value here is supposed to be pass, but it predicted fail. All right, that are the consideration for that. So that means it picks all the true positive TP plus TN divided by the total. So true positive simply means that, oh, you're supposed to predict this person passed, and the actual value there is also pass. While true negative simply means that it's supposed to predict, it's supposed to, the real value there is pass, but it predicted fail. That's an example of what those values might mean. All right, that's an example of what those values might mean. All right, false positive. What's false positive? That means that it's supposed to be fail, but it predicted true. The other part can also be what? False negative. False negative simply means that it's supposed to be fail and it predicted fail. All right, because when you are doing your in our confusion metrics, as it were, those are the four values you are expecting in your statistics. This guy is supposed to fail. Did he actually fail? This is supposed to be passed. What did you predicted? So is it that a true value or a negative? Is it a true value or a predicted value? So is it true positive or true negative? Is it true? Is it false positive or false negative? That is a picture of what that means. All right. Those are the four results you're going to get. I'm just asking to come back with that. True positive. I'm using a scenario whereby you're trying to predict if somebody is going to pass an exam or fail an exam. True positives means that the value is at that state is that the person passed, for example. And it also positive here means that it also predicted that the person passed. All right, that's what it means. True negative means that the real value is that the person passed, but it predicted that the person failed. That's what true positive and true negative. So we need to get the accuracy of, so this accuracy we have been getting here, what it's doing is that it's picking all the values that we have as predicted. All right, true positive, the one that is correct, and the true negative, it does that addition and divided by the total number of records to be able to get the accuracy of the result. So what that represents is that the overall correctness of the data, and of course it works best when the data set is balanced, and most of the times our data sets are not always balanced. What does balance mean? It means that you can have more fail than pass. It means that you can have more pass than fail. It means that you can have more failed than pass. So that kind of case is not a balanced class, and most of the cases you will not always have a balanced case. All right, all right. You might not always have a balanced case. Okay, you might not always have a balanced case. So most of the time you have to do, I told you about that last week, but don't worry, all of these very critical cases, we'll look at them in our work. But the reason why I make this material one by one is that so that you can know the material, you can go and check for certain things, because there are many things to learn. All right, but the easiest way is that we should have our materials in a way that you can go and check them. Okay, another one we have is what we call precisions, and these are very good concepts. For example, precision focusing on quality of positive prediction. That is, did you predict it right? It's supposed to be pass. Did you actually predicted pass? So you're looking for, focus there. All right, focus there. You are supposed to predict what is true. Did you actually predicted true? So to calculate your prediction is true positive divided by true positive plus false positives. Don't stress yourself with these grammars. I've given you the scenario. All right, I've given you the scenario. So let's look at this together again. For example, here we're looking at um okay, let's make this mark down. So I've told you what is true positive. True positive is the true value is pass. Positive we mean predicted past. All right. So for example, so true false positive. That means the true value is what is failed here. Predicted past. That's what that means. All right. So just trying to show you what these guys mean. For example, if you have fail, you've done that already. I'm just trying to show you how you can interpret that. Okay, so so that you can take note of that. But trying to check here, some people are asking a few questions. What saying? Do we need to split 24 portion? Yes, you should, unless you have very small data whereby you just use your X directly. So you need that because you need a portion of unseen data for it to work. Okay. What is false positive? So from what we are doing, what will false positive mean? Um, I've already explained that false positive is the true value is failed. They predicted pass. That kind of, so don't forget that the value you are going to put here is based on the kind of problem you're trying to solve, right? False negative. The true value is true, but predicted what's it called now? Is pass rather. Pass, but predicted fail. The true value is failed, but predict. So you can see it's a more of an interchanging case, all right, for things like that. So we have the precision, we have the real com, we have the F1 score, we have the AUC ROC, we have the AUC PR, and all of that. So I'm going to stop here today because I know that we've said a number of things. That you might need to take time to look at, all right, because those are the values that are very important at the end of the day. So from here, let's take questions. But like I said, I'm going to stop here. And I'm giving another assignment now because these are very key things that you should be aware of. I've given an assignment the other time. One is, where should I use a model? Where should I use a model and their use cases? Assignment two, explain explain the meaning of the evaluation metrics for regression problems and classification problem. Okay, so please let's take note of that assignment. This is just you doing your research so that you can, you know, take notes and know when best to use these guys. So, so the second assignment is read about read about. Yeah, I'm taking the question again. The first question was on go through your models for either regression or classification and talk about when best to use them, the best use case scenario for each of those models. For example, when should I use logistic regression? When should I use, that's primarily what I'm asking you to do for the first task. The second task now is eh, try to understand all the metrics and their use cases. What do they mean for regression problems and classification problem? Yeah. So those are the two assignments that I have dropped. Right. Those are the two assignments. This is going to be submitted. Please don't go to ChatGPT. You are not helping yourself. This is what you should understand. All right. What you should understand. There are many articles that will explain this. I don't need to take your time to look at it fully because it will help you when I give you data set now. I'm not going to be the model for you. I'm just going to give you data set and tell you the problem. So you will be the one to find out the best metrics before from next week now. Next week is more like your first mini week for projects. All right. Maybe even Wednesday is going to be, well, I'm going to be on class like this, no class. I just give you data set and you begin to work. So you have to know these things by now, right? Not that you completely know them, at least these are the things you need to make research on. It's going to be handy. Because in tomorrow's class, we're just going to talk about how to undo imbalance classes, for example, how to know overfitting, and how to do some, cross validation. That is when your model is overfitting. I've not explained that. I'm going to explain that in tomorrow's class. So we're going to stop here today. Like you still have time to go through these things again. I know some of us are hearing these things for the first time. That's why we are making the classes a bit short. One of your colleagues is going to help you drop the assignment in the LLM, or you can watch the video again and pick them up. What is saying project? Oh, yes, now there are no other ways. You can see people even in the group already doing some many projects. There are no better time than now. You understand? There are no better time, and don't forget that we are already in our 6th week, which means we only have more like 2 weeks to go from this week. All right. So gradually we are winding up. That is why the things that we are learning, there is a need to look at them critically. Who is this comedian? I said you should not use ChatGPT. Say you can use Gemini. You can. Hey. Any other question? Okay, question is what percentage range should our testing size be relative to training? Initially, I thought it should be 30 to 70. Yeah, it depends on you. It depends on the experiments, right? You have 80 to 20, 70 to 30. Depends on you. All right. So most times it's all about you who is building. All right. So are these groups are there going to be groups? Or is it going to be done individually? Anything we are doing is going to be individual. But of course, you can always ask your question. Your colleagues can help you out. At this stage, do it yourself. At this stage, is do yourself. There are many problems to give. Don't worry. I've been here for about 10 years, so I can tell. I can always get 1,000 of problems to solve. It's what I do every day. So, is do it yourself. Okay, so for people who are just joining, like I mentioned, please, all you just need to do is critically make sure that you go through what we are doing. Somebody say what percentage accuracy is better? Of course, if your method is anything, is over 100% now. So anything from 70 is good. 80 is good. 90 is good. But the point is, hope is not overfitting, which is what we're going to start treating. The technicality of how the model is performing. Hope is not overfitting. Is what we now want to treat now. Do you get it? But for accuracy, for most of the classification problem is percentage. The bigger the percentage, the better the model is doing. If it's 50, it shows that the model is just on an averagely good. 60 is good. But you know that 70 is better than 60, right? So that kind of thing. So I think that's people are already asking me how to submit assignment. I've told you. Any assignment I want you to submit, I will provide how you are going to submit. Don't ask me. First thing, go and do it. And of course, do it well. Because and I'm being sincere to you, the likelihood of me checking your assignment is very slim. But the better thing to do is do it. The only time I'm sure I'm going to check is when I give you projects, when at that point, I'm obviously going to have to go through it almost line by line. Right? So when I'm asking you to do anything is primarily for your sake. So do it well, understand it well, so that if I glance through it, you are still on point. We have more than 500 students in this class. So if you submit anything, the likelihood of checking everything is very slim. But imagine that it's your own I checked and you fall my hand, So please, I've not given any serious assignments now. I'm asking you to just make research. Somebody's already asking me for timeline. Don't stress yourself with that. Just make your research on the two questions. So somebody should also drop the assignment on the LMS and also on the chats, on the WhatsApp groups, so that people can try them. These are just learning, nothing serious. I've not given anything. I don't know why when we hear assignments, we are saying when we just feel I'll say something. What I'm asking you to do for now is just making basic research, nothing serious. So we're going to stop here now. So please do well to go through the material. I know it's getting advanced, but trust me, if you have been paying attention to what we have been doing since the beginning, we are still on that lane. The people are saying that I should start, there is nothing I'm going to start. We're going to continue what we have done because we want to peep into some other things just to give you some ideas. So I've done preprocessing. I've taken 2 days to do preprocessing, to do data cleaning. I'm not going to do that again now. You are going to leverage on that. Go and check that material. Go and check that video again. If there is anything you need to come, we have spent almost a week on that already. So at this stage, we don't have that level of time to now start checking what we have done at that stage before. So please do well to go through your videos. Do well to try them out, and kudos to people who are trying it out, because the beauty of what we are learning is that once you're trying it, it becomes part of you. All right, it's what I've been doing for almost every day in the last 5-6 years. So it's what I do every day. If I'm leaving this corner, that's what I'm going back to do. So as you do it, you become a master in it. As you do it, you know what to do. And like I've told you, your job is not to cram the code. Your job is to understand the process. The code you want to write is already on the internet, it's already on ChatGPT, it's already on Gemini, right? But you need to understand them, step what you need to do per time. I've not said good night. People are already greeting me good night. It's okay. It's okay. I've never said good night. You're already saying good night. I don't understand. But if you are leaving, safe journey. See you tomorrow. Okay. So please, let's do well to follow everything in the material. Let's do well to hey, let's do well. Hey, let's do well to watch the videos. Good night. Hey, good night, everyone.